For as much as I don't like browsers, they have a very interesting capacity, I guess, to do entirely client-side processing, to keep things off the wire. So if I transmit data that is encrypted, and I mean manually encrypted or something, across the internet, across the routers it traverses, and across my own home ISP, that data is unencrypted. Rather, it can be monitored by anyone who's there, which we'll assume is lots of people, if only for metadata. It's like if you use PGP, then you are one of the few people in the world that uses PGP. And if you're an ISP, you can track at the endpoint, actually very valuably at the endpoint, because you have actual addresses and confirmations of whose modem is whose modem. Like, you've got names and addresses. You can track, hey, this person, literally this client, this address, phone, or rather home address, is receiving PGP encrypted emails. That's much more valuable to track. But I digress. If you have other encrypted traffic that's, I mean, if you send it across HTTPS, there's like tunneling and wrapping you can do with that to make it less visible, obviously. But the browser has the ability to receive that data and process it locally and decrypt it locally. Because the thought has always been to create some type of web service or web application that will make the encryption and decryption and communication process easier. But then you have trust. And where there's trust, there's an opportunity for exploitation, or an opportunity to, submit a FISA court order that comes with its own compulsory gag order and all that fun stuff. So if you simply host the encrypted data, then you don't know what the data is, so long as the data is client-side decrypted. Further, you don't have the ability to decrypt that data, even if you subvert the application. That's something that people would do after they purchased the website. Purchased or otherwise obtained, seized the website is probably the right term. You host the encrypted data gets transmitted. People are more likely to just kind of listen to it on the way in and out, rather than try to own it. But a browser can do JavaScript, pretty simple, single-threaded processing. I don't think AES 128 is compromised. I don't think so. That's just kind of a gut feeling, though. You can go 256, but I don't know. So the browser has the ability to get this data. The cool ability of the browser is that it can graphically represent textual data locally on your client system. So if you have a browser open and you fill that browser page with a bunch of encrypted text, just gobbledygook, top to bottom, base 64 encoded probably. Take all that data, decrypt it into text. That text can be, it can be images, it can be HTML code, it can obviously be formatting. And once it becomes that text, it can be readable by the browser itself and representable by the browser itself. So imagine this is trying to improve communications and put it on a channel that's separate from outside vendors' influences. This is something I did with Facebook a while ago, where I made a bookmarklet that would take encrypted data that was presented on Facebook, and it wasn't an app. That's right. Yeah. Oh yeah. And then Chrome. Oh wait. That's interesting. So when I made this, I was like, okay, I want to be able to represent this data, but I want Facebook to host it and to not know what it is. So I'd post encrypted data to Facebook, and I would run a bookmarklet, which is a bit of JavaScript that runs against the current page. Well, Google Chrome, like literally a week after I made this and tested it out, Google Chrome was like, hey, so we're not going to do any kind of cross-site JavaScripting, period, because of most securities. And I was like, well, I guess I understand. And the answer is no. Now I really understand why they didn't want that. I don't know, maybe not. It might be an actual security thing. They own the browser, so it doesn't matter. The point is, Chrome was doing it. And if Chrome's doing it, then, like, at this point, who cares? You should get off Chrome. You should get off Chrome. You should get off Chrome. Low battery. Let's see what happens. But the bookmarklet would take your currently open Facebook page that has a post in it that's encrypted text, and it would decrypt that text. I guess you probably want it really super tiny, and translate it into something that's client-side, represented by, you know, whatever the text of that post is. So it decrypts the encrypted Facebook post, and it does it entirely on your client side, or on your client browser, or on your phone browser. And once it does that, Facebook has no idea, basically. Ideally, Facebook has no idea, because it's presented you with encrypted data, and you've, on the client side, decrypted that data for your viewing. And it probably could do a little like a flip and a flop, so that when you click it and hold it down, it shows it decrypted, and then when you release it, it shows it re-encrypted. Maybe a JavaScript alert would be a better way of handling that. It's a separate system, and it wouldn't update the code. Yeah, maybe. Yeah, that would run straight through the Java decoder. But anyways, you would receive a message. It would be encrypted. You would be in your normal Facebook, in your normal browser, or on your normal computer, and you would click the button and it would pop up. You would see what the decrypted message was, and Facebook wouldn't know. Facebook would be hosting the data, but they wouldn't know what the data was. They'd be able to know that you saw it, but that's about it. And then if the data is not intended for you, you would click the button and it would say, this is not for you, go away. And you would go, okay. That way it could be untargeted and impart some deniability anyways. So that's pretty cool. That was the idea originally. We got off Chrome anyways, so maybe that's on the table again. Bookmarklets. Yeah, they said that if you wanted to do that kind of stuff, you had to make a a browser extension, which, like, no. So doing something like that would let you change the data that's on the web page and use them for hosting. So you could use Facebook still, but it would deny them the information that's on it. Further, you can use it with, what's that called? It's like a picture encryption or decryption, where you can create a picture in hex text, and the browser generates it as an image. So you basically get a decoded or an encoded image in text in base 64, or I thought it was in hex. And then the browser would show it as a picture. There's a way to break this down so that we're using their venue, but we're denying them the metadata and the content. I'm not sure what it is yet.